Good day, students. Welcome to this last tutorial for this part of social research methods. I want to talk about testing of hypotheses, and SPSS can do this for us. So I opened the old SPSS file, which you used in the first and the second tutorial. For the third tutorial, you have to open another SPSS file, but for my convenience I open this one, and we see the variables we already looked at, and here we see gender and here we see age, and these variables I'm going to use to test some hypotheses. For instance, we had little under 1900 test subjects in our sample, and one of the questions you could test, or one of the hypotheses you could test, say, is the average age, the mean age, 50 years old in this sample? Now let's test this. And how to do this? First of all, you go to Analyze, go to Compare Means, and choose for one simple t-test. Click on it. Which variable you will want to use? Age. So our test variable is age. And what is the test value? And here you put the value that you would normally state in your H0 or in your basis hypothesis. So that's your ground hypothesis, your completely unbiased, completely no bias there at all. You say, yes, I assume it's 50, but actually you think it's quite different, but you want to test this. So I'm not going to into it too much in detail, but this is more the practical side from how to use this. So you want to test it on, let's say, 50 years old. Could it be that the actual mean of the population is 50 using this sample? We can click on options. Yeah, there are not a lot of options here, but more in the sense we can change this. In that sense, we want to change it, for instance, to 99%. Whatever. Okay, you click on OK, and what do we see? SPSS generates an output. First, some descriptives. This 1889 persons in our sample. The actual sample mean was 48.62, standard deviation 17.72, and our standard error is 0.408. So everybody knows how this thing is calculated. It's nothing but the standard deviation divided by the square root of a little under 1900. Okay. Now to our test. First of all, we see this t-value, and everybody knows we have a lot of test subjects, so this t is quite similar to our z, or standard normal distribution, but the t distribution, the student d distribution, is always more accurate. Perfect. Okay. Now, how about this minus 3.381? How is it calculated? Now, you should know this is not that difficult. This number, it is calculated by this mean minus 50 divided by the standard error. This is how we get this minus 3.381. So the mean minus 50 divided by the standard error. Then we get the degrees of freedom. It's nothing but the number of observations minus 1. The p-value is very small, let's say 1,000. In that sense, we could reject our first hypothesis and accept the alternative hypothesis. So this is what you probably know from your lessons from Dimitri. So it's stated here, SPSS does it for us. In that sense, this is maybe somewhat different. The mean difference, this number, it's very easy to calculate. It's nothing but this 48.62 minus 50. This is the mean difference, the difference of those two means. And this confidence interval for those difference in means is nothing but this number plus 2 times the standard deviation. Then we get this one. So this number plus 2 times 0.408, we get this number, and this number here is calculated by this number minus 2 times the standard deviation, standard error, I should say, excuse me, minus 2 times the standard error. So this is how it is calculated, and maybe it is easy for you to learn, probably is not in Agresti and Finlay, that if 0 is not part of the confidence interval of the difference, then we can also reject the H0 hypothesis, and we can accept H1 or the alternative hypothesis. So this is what we see here. Think about it. Okay, this was a test for continuing or continuous data, let's say interval ratio scale data. Let's do another test. We don't want to save this. For instance, if we want to use gender, then there were males and females in this sample, and if you don't know what a 1 meant, a 1 was a male and a 2 was a female. And if we want to test this, we could test this by just asking us this, the question that we could say, yes, 50% of all the people in this sample were male. So this sample is 50-50 distributed. Or actually I should say, maybe the population is 50-50 distributed. Okay, now we go to analyze. We're not to compare means, but we go to non-parametric test, and we choose for binomial. And what do we want to test? We want to test gender. And what do we want to test it on? Let's say it's already, the test proportion is already here. So here is, we fill in our hypothesis. In that sense, 50%, it's always there. But you can change this. You could also say, yes, I want to test it on 30% or whatever. But just keep it at this 50%. Do we want to have some options? Maybe we want to have some descriptives. That will be nice. Okay, we click on OK. And what do we see? First, the description, a little 1900 people. In that sense, this mean is bogus. Everybody should know this. This is just adding up those 1s and 2s and dividing by the number of 1s and 2s. This is bogus. Why? This is nonsense. Because we all know sex or gender is nothing but a categorical or a nominal variable where the mean doesn't mean anything. This is our test, and this is quite sensible. In that sense, what percentages did we observe in our sample? Let's say 54% of all people were female and 46% were male. We tested it on, let's say, is it possible that in the population, let's say, it's a 50-50 split? No, it's not possible, because here we see our p-value again, and this p-value is very small. It's 0.0000. So we can reject the H0 hypothesis and accept the alternative hypothesis that it's not 50%. This is what you should know. And this 0.00, maybe I can go into a little of that. Click on it, and if you click on this number, it's not actually 0.00, but you see there are some numbers. But it's very small. So you should know this. It's never actually precisely 0. Okay, and you see it's based on this approximation of the standard normal distribution. Okay, maybe this was a little quick, but this is how to do it. The comprehension about the content you should get during class. Okay, thank you for your attention.